Let's take a look at this question over here. We're given a spring of spring constant K with natural length L sub 0, and attached to it is a mass, is just an object of mass m with angular velocity omega, which is like a W upside down m, however you want to think about it. And what we're asked to find is the elongation that this spring is going to experience due to the rotation of this at angular velocity W omega, as I mentioned. And the way we can find that is by equating the centripetal force of this. The equation for centripetal force in terms of angular velocity is m omega squared r. Right? You might be more familiar with mv squared over r, but since v over r equals omega already, we can write this thing, right? Because v over r is omega, we can just write this as m omega squared r. So these are the same thing. Just make sure you stay clear on that. Anyway, this is going to be our centripetal force. Over here, what is r going to be? R is going to be the whole length. It's going to be L sub 0 plus delta L. And how do we get this? Like, how is that force actually going to be supplied? It's going to be supplied by the spring force, right? The spring force is just the change in elongation. So that will be K times, that's the spring constant times the change in elongation. So K times delta L. And again, what is r going to be? Well, it's going to be, so I'll write the rest of it, m omega squared. R is going to be this total length, right? L sub 0 plus delta L, this entire thing over here. Because that's the radius about which this is rotating. Okay, so let's write that down then. Delta L plus L sub 0 is equal to K delta L. And now we need to just solve for this, right? So it doesn't seem that difficult. We can just expand this out a little. It might get a little messy, but we should be able to handle it. I think it's not that difficult. So let's isolate the delta L by bringing all the delta L terms onto one side. That's going to leave us with this on the left hand side, and on the right hand side we're going to have K minus m omega squared delta L. Divide both sides by K minus m omega squared, and we're going to get m omega squared L sub 0 divided by this is our change in elongation.